our next presenter is Bojan, and he will be presenting exploiting esoteric SQL injection vulnerabilities. So, welcome.
Right. So, thank you, and hello everyone. My first time here at Balkan, not first time in Novi Sad. So, very excited to be here. So excited that I actually have a couple of live demos today, and you know how it's always difficult with live demos. So, depending on, if I prayed enough to the demo gods, those live demos will work. If not, then we'll stick with the slides, but let's hope that it'll be okay. So just a little bit of agenda for today. I'll just have one slide about myself, and then since there are people with different background here, I'll spend a couple of minutes on SQL injection 101, just to make sure that everyone will understand what I'll be doing later. Because the one thing we don't want to be script kiddies, right? We don't want to just fire up commands and then let them do something. We actually want to understand what's going on in the background. I'll talk a little bit about in-band or inline and blind SQL injection vulnerabilities, and then I will hopefully successfully demo two very esoteric SQL injection vulnerabilities that I nevertheless found in the wild. So these vulnerabilities are from real-world applications, but obviously I will be running them in my isolated environment here. The funny thing is that the last one that I will exploit, absolutely no tools that exist today will find those vulnerabilities. And they still exist. I can still exploit them, and hopefully we will all do that together. So just a little bit about myself. My name is Bojan Zdrnja, and finally I'm at a conference where I don't have to repeat my surname, because all of you can hopefully, at least local guys, can read it. I work in a Croatian security company called Infigo. Some of you guys know me from before. I'm also one of the SANS instructors, so I teach two courses, 504 and 542. 542 is a web application penetration testing course, which is something I draw all the ideas from. And if you want to know more about SANS, let me know. Unfortunately, I have to leave today, so you'll only have maybe half an hour after the presentation to catch me. But Twitter is here, emails are here, so feel free to hit me up if you need anything. So why SQL injection? I think it's pretty much obvious, right? So with all the other web application vulnerabilities, SQL injection is the sexiest one. Tonimir over there will be presenting tomorrow on some, let's say, less exciting, but still, nevertheless, very interesting web application vulnerabilities. So if you're here tomorrow, I definitely encourage you to go and listen to him. If nothing else, he's a funny presenter, so I'm sure it'll be a good presentation. For me, SQL injection, that's what I'll be talking about today. So, what's SQL injection? Well, it's one of the subcategories of injection vulnerabilities, and injection vulnerabilities are still so common in web applications that since 2010, in the OWASP top 10 vulnerabilities list, injection vulnerabilities are at the #1 spot. So they're very, very prevalent, and here we have all sorts of different injection vulnerabilities. We can have SQL injection vulnerabilities, where obviously we can impact the way that the web application sends the data to the backend database. And since we can control the parameters, as we will see later, we can actually make the SQL database do something else. We can also have like OS or command injection vulnerabilities, when we can influence some commands which are executed by the web application at the backend system. LDAP injection vulnerabilities. Could we have no SQL injection? What do you think? Yeah, we can. It's maybe not as powerful as SQL injection, because the NoSQL databases, I don't know, MongoDB, for example, they limit us quite a bit in the queries that we can issue. Sure, sometimes you can execute JavaScript on a NoSQL database, but in a typical standard web application, we can still have NoSQL injection vulnerabilities as well. So maybe topic for next year's Balkan, maybe for me, maybe for someone else. Today, I'll talk about plain, normal SQL injection vulnerabilities, but as I said, they will be a little bit esoteric and not that easy to maybe detect or exploit, as we will see. So why do we have SQL injection vulnerabilities? This is the part where I'll go through some basics. So for some of you who maybe worked with SQL injection before, just hang with me for a couple of minutes. If you don't know much about SQL injection, this will be a good couple of slides just to bring you up to speed. So SQL injection vulnerabilities, and actually any injection vulnerabilities, exist because we have a need to have interaction from our front end, and that front end is typically a web application, but it can be anything, with a backend database. So virtually any web application today, unless it's a static and simple web application, will have some kind of backend database. It can be MySQL, Microsoft SQL Server, it can be Oracle, DB2, Informix, whatever you want. But typically we'll have a front-end web application, maybe some kind of middle layer, and then our database. So the interaction with the database normally depends on user activities. When we click in our browser on a window and we want to sort something, normally what happens is that either the application already has the data and sorts it for us, or it will issue a SQL query to the database, and that SQL query will actually contain certain input that is received from us. So indirectly, we can actually modify the SQL query that is being passed by our web application front end to the database backend. So this data, since it's sent to the database, it's parsed by the interpreter. So it is a part of the query which will be passed by the web application to the database, and it will be executed by the SQL interpreter. So normally, virtually every web application today will use a single account to talk to the database. That's how web applications normally work, because it makes no sense for every single user, our front-end client user, to have an account on the database. It really wouldn't work. The performance would suck. So what happens is that the web application normally uses a single account to talk to the backend database, and this account normally can read absolutely everything. So the developer actually relies on his own application to do proper authorization and authentication of users. And then the web application will decide, okay, this user can read certain tables or can retrieve the data. You can see probably now where SQL injection comes into play here. If we can modify the query that is being sent by the application to the backend database, since that one single account can read absolutely everything, we can get the data out, no matter if our user is authorized to do that or not. And that's actually what we're going to do with the demos that I will show in a couple of minutes. So before we start, a little bit of refresher as well. Some important SQL verbs. I'm sure that you're aware at least of a couple of them. Obviously, with select, we want to retrieve data from the database. We read something from a table. With insert and update, we can modify the data. Again, depending on the way the web frontend is actually using the backend database, we might be able to modify the data or not. In most of the databases, if we have a select query, we won't be able to modify the data because select query can only read. If we can insert or update, then it's basically game over. Delete, hopefully, account that we are using, that one single account that the web application is using, shouldn't have delete privilege unless it really has to delete some rows. If it can use the delete keyword, then it's probably even worse for the database. And finally, union combines the results of two selects. We won't have to use union in today's exploitation, but it's good to know. Another important thing are SQL modifiers. So with SQL modifiers, we can actually extend the SQL query and be very specific on what we want to retrieve. So our SQL query can be, for example, select star from table users where ID equals 1. So that's like a very, very small, easy query. Again, if this ID parameter is something that we can influence, then we might be able to extend the SQL query. With and on or, we can narrow the SQL query in the where modifier. Just one more slide about special characters. And these are the ones that, make all the fun for us. So obviously, I'm sure that you all know about single tick and double quote, the one character that can break absolutely every single SQL query unless it's properly filtered or encoded. So yeah, typically every penetration tester, every hacker, first thing they do in a field is put single tick, right, just to see what happens. So yeah, don't do that on your bank because you'll probably have difficulties explaining why you entered single tick into a numeric field. Like, yeah, I accidentally typed it. It won't really work, it's numeric field, don't do that. So do this only if you're allowed to do it. String delimiters, important for us, so we can try to break out of strings. We can maybe even exploit SQL injection vulnerabilities with these being filtered. I'll have one example with that. Comment delimiters, dash dash, hash character, or typical programming comments, string concatenation, and so on. One thing that is important, calling functions. So we can have a subquery. In our query, we can inject a different query. So the database will first run a subquery, select 1, 2, 3, and the result, 1, 2, 3, will be returned back to the outer query. We will use this quite a bit when exploiting SQL injection. So let's see a very, very basic example. So this is a PHP web application, and this is our poor developer who made a very, very basic and typical SQL injection vulnerability. So what is the developer doing here? So he's trying to retrieve all the transactions from a table called transactions, as you can see here, select star from transactions, where source, maybe source account, equals some ID value. And this ID value he's actually receiving from the user, from the web application. So in our web application, when you click on something, the ID parameter, the value of the ID parameter is being sent to the web server and then subsequently passed all the way to the SQL database. Okay, I hope this makes sense even if you're not familiar with SQL engine. We can simply see here that the ID parameter is literally taken and put into the SQL query, no matter what's in this parameter. So if we take one of the dangerous characters, single tick, and if we put into the ID parameter single tick, check what happens. We actually break SQL query, right? Because the original SQL query becomes invalid since it should be select star from transactions where source equals single tick, something, single tick. That's what the developer did here. However, when we put our single tick, we actually break it. We now have an uneven number of single ticks, and this simply breaks the SQL query. Depending on the web application, it might range from those very, very simple, easy to hack web applications. When we do this, we actually get an error back, which says your SQL query is incorrect. Or we could have applications that gracefully catch exceptions. So a better, I won't say good because it has SQL injection, but a better application should actually catch this error and simply print back and say an error has happened. So we don't know what actually happened in the back end. We know there is an error, but we don't know exactly what. And this I will exploit later. These are called blind SQL injection vulnerabilities. So how do we exploit this? Well, remember, since we can inject whatever we want into the query, we can actually extend the query. So if our input becomes single tick or 1 equals 1, then check what the resulting SQL query will be. The resulting SQL query will say select star from transactions where ID equals single tick, nothing, or 1 equals 1. 1 equals 1 is what? It's true. So this will print back what? The whole table. Because every single row will match, right? ID equals nothing or true. Everything is true. So we get back absolutely the complete table. Now this is a very simple example. This is like SQL injection 101. And typically when you try to do this, even some like web application firewalls, intrusion prevention systems, they will catch this. They will check or 1 equals 1. Oh, I know this is bad. Does it need to be or 1 equals 1? Can it be or 2 equals 2? Sure it can, right? All I need to do is have the right-hand side become true. So I can put whatever I want. You will see through the presentation why it's increasingly difficult for web application firewalls, intrusion prevention systems, basically any system that uses only a blacklisting approach to actually prevent us from exploiting SQL injection. We can always actually do that. So before diving into the demo, hopefully the demo will work, just a little bit more introduction. I already mentioned the difference between inline or visible and blind SQL injection vulnerabilities. So with inline SQL injection vulnerabilities, when I do this, I'll actually get some kind of an error. I get the results of that query. With blind SQL injection vulnerabilities, I don't see the result directly. So I know I messed up the SQL query, but the application prints back an error has happened. So I need to find a clever way to actually deduce on what's happening in the background. So maybe I can somehow modify the SQL query to figure out if my query was executed correctly or not. With this, I will get two cases, true and false. My query executed correctly, my query failed. So by having true and false cases, I will be able to deduce on what actually happened in the background. So let's see typically how we can exploit this. Let's see the outcome of the following requests. So this is something I just do in a browser. To be honest, I can actually even exploit this sometimes from a browser. It's not the most convenient way to do it, but in theory I could do it. So let's see a couple of examples. This is something I normally do when I test for SQL injection. So the first URL and our vulnerable parameter is release ID. So when I normally surf through the web application, it has the value of 1 and this works. I get a web page back. And let's say this is some kind of media website or whatever, so I get one page back. I know exactly which one. It says BalCon 2018 starts today. Okay, great. Then I modify the release ID parameter and I put something like character A. And I get back a blank screen. Okay, this could potentially be some kind of an error. Depending on the web application, maybe the SQL query itself had an error, or simply there are no results from the SQL query because there is no release ID article with value of A, right? It has to be a numeric value. So with 2, I try number 2, it works. I get a different web page. So the first web page says BalCon 2018 starts today, and the web page with release ID equals 2 says something else about, again, BalCon being in Novi Sad. I don't know. Notice what I have here. I have two cases. When the value is 1, I get one page back. When the value is 2, I get a different web page back. When the value is A, I get blank screen. So now what I try to do is the fourth case here, 2 minus 1. And I get back the first web page, which is the value 1. This means that something actually performed this operation for me. 2 minus 1 equals 1. Would a developer do this? Not really. I've never seen them do this because it makes no sense. He simply takes the value of this parameter and then passes it somewhere else. So what else could have done this operation, performed it? The SQL database. So when I pass this to the SQL database, and when I say select star from articles where release ID equals 2 minus 1, the SQL database will say, oh, wait, you want me to actually perform this operation for you, so I'm going to do it. 2 minus 1 equals 1, and I will retrieve back the article 1 and show that to you. So to test it, I put 10 minus 9. Again, I get the first web page back, which means that something is performing calculations for me. I can put something more complex here, and this is actually what I will base my exploitation on. So now, that I know that I can somehow influence what the database engine is actually doing, I can try to inject my own SQL into this parameter. Remember from a couple of slides ago, subqueries, when I had select 1, 2, 3 in parentheses. What if I actually try to inject that? I could maybe arbitrarily extend the SQL to do something that I wanted to do, and then that subquery returns back either 1 or 2. Depending on what the subquery returned back to the outer query, I will get either the first web page or the second web page. Do you maybe see where I'm going? I can try to extract one bit of information at a time. Is the first character in the first table A? Yes or no? If it's A, then the result of the subquery can be 1. If it's not A, the result of the subquery can be 2. Depending on the web page I get back, I can decide what was the result of the subquery. So these are the true and false cases. And this is something that we will exploit. So let's see what we can do here. We have two cases. The first one, select star from transactions where ID equals something. Remember, we can inject into the ID parameter. This is the same example as I had previously. So select star from transactions where ID equals something and 1 equals 1. So this is something and true. I get one web page back because it was true. Select star from transactions where ID equals nothing and 1 equals 2. This is false. So I get a different web page back. So by deciding what web page I got back, I know if it was true or false. So let's try together to extend the right-hand side. Check what I'm injecting here. I'm injecting a subquery which says select lower substring user 11. Anyone knows what this will do? It will take the username that the web application is using to connect to the database. That's what the function user does. With substring, we will take one character, first character, okay? We will convert it into lowercase, and then we will check if this character is A. If it is, then all of this will evaluate to true. If it's not, then it will evaluate to false. See what I have? The first two cases. So if I guessed the first character to be A, then I get one web page back. If it's not A, I get a different web page back. And this way, I can guess one character at a time. Will it be fast? Not really, right? One character at a time. I can optimize this. I can do a binary search here. So I can say if the first character is greater than M. So if it is, if it's not, then I know it's less than M. So I can do a binary search. It'll be a bit faster. And there are ways to optimize this. It's still relatively slow. But you can see how I can get one bit of data out from the database at a time. So enough of slides. Let's go to some real-world demos. And again, yeah, demo gods, please make this work, but we'll see. So I'll have a couple of examples here. I will be using one of the well-known web application penetration testing tools called the Verbs suite. If you do any web application testing, this tool is the tool to have. I love it. I use it all the time, but you will see how it will fail miserably here. So I'm not bashing the authors. I think they did a fantastic job. I will just show you how you cannot rely on a tool, because the tool will actually miss the vulnerabilities. So let's see the cases here. The first, SQL injection. This is the simplest SQL injection in the world. Okay? It cannot get simpler than this. Then, case 1.1. Again, very, very simple. But do you see the difference? Check the one here. ID equals. Check the one here. ID equals. There are no single quotes. Okay? I don't need them because ID is numerical. So I don't need single quotes. I need them when I have strings. So for numerical parameters, I don't need them. Case number 2, the developer just decided to add certain value. We'll skip to case number 2 because I won't have enough time to do everything. But the application that I'm hacking will be on my GitHub over the weekend. So if you want to play with that, feel free to download it. Okay, So what do I have here? This is my server. It's not interesting to us because all it's doing is running the web application and the MySQL database. And this is my hacking Linux that I will use for demo. Black screen, green, yeah, has to be like that, okay? If you don't hack like this, then, I don't know, go and watch The Matrix or something, because it's like... So what do we have here? I will go to this web page. I will explain later what I'm doing here. The second, let me see the IP address here, because it probably changed. Um, 138, so okay. Live demos. Cool. All right. So here we have 5 very, very simple web pages, and they all have SQL injection vulnerabilities. So we will now exploit the first 2, SQL injection 101. Those are the ones from the slide I had previously. The last 2 we will exploit as well, but they are very, very complicated. Well, not very complicated, but for the last 2 examples, as you can see, there are some filtered keywords. Why do we have filtered keywords? Well, quite often developers want to prevent us from exploiting SQL injection, or they have a web application firewall, which might be blocking when it sees sleep in a query, or benchmark, or union. These are the keywords that we normally use when exploiting SQL injection. So sometimes web application firewalls will drop that. Sometimes developers will drop that. But we'll see there is a way to go around it. So let's first exploit first 2. So what I'm going to do here is I have my browser, and browser is actually sending traffic through Burp. Burp is the tool I mentioned previously. This is a proxy that you can run on your own machine. So you can have your browser actually sending traffic through the proxy. So I will see all the requests and responses that my browser is sending and receiving back actually in this tool. So when I click here on the first link, I actually get some results. And in the URL on the top is one big number, the ID. You can't see it now because it's white on white or gray on white. But over here, when I go to Burp, to history, this was the request that my browser actually sent. See the request? Transactions 0.php and some big ID parameter. So I will use Burp. Burp is actually a web application security scanner. It can find vulnerabilities. I will use Burp to check this web page. So what I'm going to do is right-click here, do an active scan. Yes. And now here, Burp is actually scanning my web application. I will do the same thing in Shell with a tool called SQL Map. Anyone use SQL Map ever? Okay, cool. So you know about SQL Map. You know that a guy from Zagreb actually, is the main developer for this. I think he was maybe at BalCon last year or maybe 2 years ago. So this is the latest version of SQL Map. I actually downloaded this today. I cloned it from Git today. So let's see how SQL Map will do. Oops. So I need to give it the URL. Let's go back here. Copy URL. So I know that ID is the parameter which has the vulnerability. So to make it easy for SQL Map, I will say -p ID, which tells SQL Map, please try to inject into this parameter. So I press enter, it will start doing something, and it's very, very fast. It already said, oh, it looks like you have SQL injection in the ID parameter. Well, duh, this is really SQL injection 101. I expected it to work this way. So we can actually let it run. It will now test some time-based exploitation. So it's doing a sleep on my server. That's why this is taking so long. So I'll let it run in the background. Let's go back to Burp and see if Burp found something. Looks red. Yeah, we all love that, right? When it's red, it's good. Green, not so good, because we are penetration testers. We want vulnerabilities. So let's see what is our vulnerability here. SQL injection, yay. So burp definitely found the SQL injection vulnerability. SQL map will find it as well, and we are all happy and good. Let's go back to SQL map. Here we go. And now if I want to, for example, list the databases, this is --dbs. Let me put it on top for you. --dbs. And there you go. I have two databases, Acme SQL and Information Schema in my MySQL database. So this all works good. Fantastic. Burp found the same vulnerability as well. Let's try the second example. So I'm going to go back here and click on this example where ID equals the parameter we inject but without the quotes. So again, I click on it, the application works. I'll go back to burp, find the request. This is my request. See the difference? This is transactions.php and the one before was transaction 0. Absolutely same code. The only difference is that in the SQL injection, I don't have the single quotes. So again, right click, do an active scan, go back to scanner. It's actually a bit faster than last time. It's still doing something, so let it work. And let's do the same thing with SQL map. So I actually know that this is just transactions.php. Yep, fantastic. So SQL map again found the vulnerability. Same story, tests for all sorts of different injections. Let's go back to burp. How about burp? Says finished. There is no red color. I don't like it. No SQL injection. So this is the tool that like virtually every single web application penetration tester uses, and it failed on finding like the most simple SQL injection there is. So lessons learned from this slide, don't rely on tools exclusively. Sure, we have other tools. If possible, always use more of them. As we saw, SQL map actually found it without any problems. But burp, the tool that we all, at least I, love and rely on, actually failed. When I saw this first time, I went to guys in my team and said, okay, for every test you're doing, you can't rely on burp anymore, at least for SQL injection. For some other categories, burp is actually good. So let's go back to SQL map. This all works. DBS. Excellent. So this works. Now let's ramp up the game a little bit, because these were actually very, very simple. So let's see some other things that we can do. Let's see some more complicated or more complex SQL injection vulnerabilities. Now, one of the things that we need to do when testing for such vulnerabilities is actually to fingerprint the database. So before exploiting, I want to know what database do you actually use. Is it Oracle? Is it DB2? Is it Microsoft SQL? I don't know, MySQL, something else. So depending on the web application, sometimes you can actually guess. Have you ever seen a Microsoft developer who uses ASP.NET to use, I don't know, Postgres database in the background? Well, it can happen. Yeah, you've seen it? Hey, buy that man beer. Or I don't know, do something. But you can rarely see that. Typically, when it's .NET, they'll have Microsoft SQL Server, sometimes Oracle if it's like a corporate enterprise application. If it's PHP, anyone uses PHP with IBM DB2? No, because you do? How much do you pay? How much do you pay to IBM for the license? Oh, it's a free one. Okay, fair enough. Interesting case. Obviously, I need to buy you a beer later, as I said. But cool. Okay. Sometimes we do have such cases, but typically, we have relationships between environments and databases. Even if we don't, luckily for us, different databases support different ways to perform certain queries. Although the SQL standard actually says how they should behave, these big guys, Oracle, they say, oh, you know what, we don't care about what the standards say. If we want to have double pipes for concatenation, that's the way Oracle will do, which is cool for us, because if I have a string that I split into two strings, and if I use double pipe for concatenation, and it works, I can actually be pretty sure that it's Oracle or DB2, because the same thing works in DB2. But I know for certain that it's not Microsoft SQL, because in Microsoft SQL database, in order to concatenate two strings, you have to use plus. In MySQL, you don't use anything. You simply put two strings next to each other, and MySQL will automatically concatenate them. So for the more complicated example, let's say that we've performed the fingerprinting, so we know exactly which database it is we are dealing with. But in the examples here, as I said, we will have a developer or a web application firewall that actually blacklisted certain keywords. By blacklisting these keywords, we will make automatic exploitation much more difficult for automated tools. So you will see that even SQL map, which is really the best SQL exploitation tool there is, will fail in finding certain vulnerabilities. So let's see again what we can do here. This is our example, very simple example, same query as before, but we are blacklisting certain keywords. If we find sleep in the query, we drop it. If we find benchmark or union in the query, we drop it. So remember those operations that we did, 2 minus 1, 1000 minus 2. By very cleverly exploiting such operations, we can get our true and false cases, which makes that we can decide what was the result of an operation. With subqueries, we will be able to do that. Let's see some examples. So first, we need to find a valid page. In the previous exploit, my valid page is the one that returns the transactions to me. If I don't get any transactions back, that's not the valid page. So I have true and false cases, as you will see in a second when I will actually exploit that. So this is what I will actually want to inject. Remember, my subquery must return a number back to the outer query. So it must be either 1 or 2, okay? Or in this case, 1000. My ID for this example is 1000. So with this subquery, what am I actually doing? Again, I'm taking, where's my mouse? Here, the username that the application is using to connect to the database with substring, first character, 1 character, then changing the case to lowercase and converting into ASCII. And now my operation will be 1065 minus the value, the ASCII value of the first character of username. If the first character is A, what's A in ASCII? 65, okay? So uppercase A. I did lowercase here, so I don't need to test it. But if the first character was uppercase A, it was 65. 1065 minus 65 is what? 1000. I get back 1 page. If the first character is B, B is what? 66, right? 1065 minus 66 is what? 999. I get back a different page. There we go. 1 bit of information at a time. So I can actually exploit that. All right, time for the other 2 demos, which are way more complicated. So again, I go back here. This is the one I'm going to do, the 4th one, the one with addition. Burp again doesn't find it. So SQL injection with filtering. So the keywords that you can see below are filtered. Sleep, benchmark, union, case, and, make, ELT, and dash dash. Dash dash is comment. I click on the web page, I get some results back. Let's try with SQL map. I don't need to try with burp anymore. Burp will not find any of these vulnerabilities. I mean, it failed on the simplest one, right? It will not find this. So let's go to SQL map. SQL map, dash U. Again, I know ID is the vulnerable parameter. So let's see what SQL map will do. SQL map will say that there is no SQL injection vulnerability here, because it tried with the default injections and it actually failed. Why? Because the default injections contain sleep, benchmark, all those keywords that the developer has blacklisted. Now at the bottom, you can see that SQL map actually says try to increase values for dash dash level and dash dash risk. Anyone use this ever? Okay, only one. You see, less people actually use this than they use SQL map normally. So what I'm going to do here is I will increase level to dash level 5. What does this do? This simply tells SQL map use more injections, different injections, in order to try to actually identify SQL injection. I could use dash risk as well. If you do decide to do that, be careful. With increasing risk, you actually add injections which could cause problems in the database. What kind of problems am I talking about? Benchmark. It will eat CPU. Or if we have an update statement, and if our SQL injection is in update, and SQL map adds or 1 equals 1, what do? We update every single row in the table. So we mess up the application completely. Happened to me, so be careful. So with dash level 5, SQL map will actually manage to find this. And the way to exploit this is the same as the one that I showed previously to you. So see? Okay? See how many different injections it's trying now. Way more than before. And now if I let it run, I can actually try to retrieve some data from the database. And this time, I will not do dash DBs to retrieve the databases. Why? I want to show to you what SQL map is using to retrieve the data. So I'm going to say here dash tables, which says please retrieve all the table names from all the databases that you have. Now check this. This is like the matrix moment, and you will see why in a second. Best thing ever, right? So what it's doing right now is it's actually trying to deduce one character, actually one bit at a time, and get all the data out. It is using some variations of sleep in the background. That's why it's getting, one character out at a time. And this is actually bashing on my server right now. If I was checking the logs, I would see the logs go like crazy. And if I let it run, it will do this until everything is retrieved from the database. But like this is the best thing, it's like matrix failing. So let's go for the last one. I can let it run. Actually, I'll stop it. So the last one, I will have to exploit manually. You will see why. So I'm filtering certain keywords, but my SQL query is a little bit different. So what I'm doing here is I'm retrieving data from the table transactions where source equals something, number, and mobile must be either literally text true or false. So the first part, ID, is non-injectable. So it's perfectly coded, we cannot inject that. The second part of the query must be true or false. Literally text true or literally text false. And it might seem that it's very, very difficult to exploit, but let me show to you in the slides first how we can theoretically do it. In order to make this a bit more difficult, I also modified the application a little bit so it doesn't return any transactions back now. So it's like a brand new empty application, right? Which sometimes I get for tests. People give a brand new application to me and say, okay, can you perform a penetration test on this application? So I ask them, can you please put some data into the application? So they say, why? Well, I want to see something in the application. If every screen says no data found, there's only a certain amount of tests I can do. And sometimes the answer is like, oh, you're a hacker, go hack it. Okay, we can't do everything. So it's always good to have certain data in the database. But even sometimes we can, go through that. So in this application, there will be no data returned back, but there will be one subtle difference in the response depending on what I did with the query. I'll show that in a second. So as I said, this is our seemingly impossible injection. The ID is not injectable. Type has to be literally true or false. So the idea here is, since we get no data back from the application, since the application is empty, is there any way for me to cause an error in a SQL query? So how would I cause an error? This is how we do it typically. divide something by 0. This will cause an exception, because we cannot divide anything by 0. So if I do select 1 by 0, that will be an exception absolutely everywhere, unless you're running freaking MySQL. Why? Because some genius that develops MySQL decided that 1 divided by 0 is 0. So it doesn't work. There is a configuration setting that you can go to and change the default MySQL behavior, so 1 divided by 0 is an exception, or infinity. But in order to do that, you have to change configuration. The default configuration, select 1 divided by 0 is 0. So this took me literally ages to figure out if there is a way to exploit this. And I finally found a way to cause an error in MySQL, because no matter what you do, there are no errors in MySQL. So in order to cause the error, I create a subquery. Okay, remember that select 1, 2, 3 that I had as a subquery. Subquery always has to return 1 row. If I return more than 1 row from subquery, I cause an exception. Which means that if I do a subquery which simply returns a couple of rows, I cause an exception and something happens bad in MySQL. So this is what I need. Select table name from information schema.tables. This is a default database that exists in every single MySQL database, which always has more than 1 rows, because we have more than 1 table names. So this is my subquery, and with this, I will use it for my 2 cases. For the true case, I will actually cause the error. For the false case, my type parameter will hold the string true. If this is confusing to you, don't worry. It's supposed to be, but I'm sure that in a couple of slides and in live demo, I'll explain why this works. So this will be my injection. Remember, my injected string has to be literally true or false. So what I'm going to do here is I will create a subquery. See the subquery here? Let's see from the inner part of the subquery what it does. Again, I'm taking the username, first character, 1 character, okay? Converting to lowercase, converting that to ASCII. So since it's lowercase, it has to be from 97 to 122, A to Z, okay? And then my if here will say, if the first character or the value of the first character is 65, then do this subquery. If it's not 65, then return the letter U from the subquery. See what we get? If the first character is not 65, we get TRUE, true. That will be our string. If it is, then we cause an exception. And by comparing those 2 cases, again, we can deduce what the result of this particular query was. Let me demo that. Make more sense. And I will be cheating a little bit because I prepared this here for myself, so just I don't have to type it in. So it's the last one, okay? Transactions 3. So actually, let me do this first. So let me try with SQL map. SQL map. -u. So I know that the vulnerable parameter is type. ID is not vulnerable. So I'll just tell SQL map, try with type again, just not to waste time. And I will increase level 5 to see if this will help. Unfortunately, I'll let it run. SQL map will not find this vulnerability because it's so subtle that there is no way for SQL map to figure out what's going on here. But let me show to you a difference. So back in Burp, this was my last request, as you can see it here. Is this visible for everyone? Yeah, I hope so. So I will send this to a module in Burp, which is called repeater. Repeater here simply allows me to very easily modify the query and send it again. I could do this from a browser, but it's boring. This is better. So when I click on go here, this is the result I get back. See? That's the same screen, right? But here I have the raw response back. If I click on render, I can actually see the burp trying to render the same page as a browser. So I will check raw here. So by testing this, remember when I mentioned that single tick character, that might be interesting. So if I put it into true here, and if I click on go, I get the same web page. No transactions found. But there is something different here. Can anyone notice that? I'm switching between last two. So take a look at this on the right side. There is something different. Anyone see the difference? See this here? So on a legitimate request, there is no break in HTML. Messed up request with single tick, there is break here. Probably added by certain part of the application that, got into some weird state at one point in time. So that's all we need really to exploit it. We have true and false cases. True will be without this break, false will be with the break character. So what I'm going to do here, I want to inject into the type parameter, and I will take the query I had before. So I will inject it here, like this. Now, since this is URL, I have to properly encode it. So for those of you who work with Burp, there is a nice shortcut, Control-U, which encodes this into URL. Otherwise, it would break the request. And now I can try to send this. And notice that there is no break here, which means that this might have been correct. So let me cycle through all the values to see what happens here. Again, Burp, there is a really nice module called Intruder. I don't have to script this. I can use Burp to do this. So I will send this to Intruder. And if you haven't used Burp, after this, you're going to love the tool. So see my query here. Remember from the slide, I want to cycle this 65. Let me go back to the slide. See this? I want to slide the number 65. I want to just simply change it. 65 to 122. Try everything from the ASCII table. So with Burp, you can do that easily. Select, add, and now here in a different screen, payloads, I can actually tell Burp, please cycle through numbers here. Numbers from 65 to 122, step by one. And click on Start Attack. So what will Burp do? It will simply take these requests and it will just repeat them constantly with a different value. Okay, make sense? Yeah? So Start Attack. And now I can maybe sort by length. And there is one request for which the length was different, 704 bytes. Why? We have that break HTML tag. So when I click on this one, in the response, if I scroll down, I can see my break here, which means that the query evaluated to false. Why? Because it had that error, right? Exception. Which means that my first character of the username is 97. 97 is what? Anyone else? Come on, you guys are at BalCCon. You should know ASCII table on top of your head. 97, A. There you go. It's A. Okay, easy for me. So what if we want to get the second character out? I simply go here and tell the substring I want second character out. Start attack again. Sort by length. Oh, it's 99. 99 is what? Sorry? D, come on. 97 is A, 99 is what? C. Okay. So, there we go. Game over for the application. We can exploit it even though it was really, really difficult, and all we need is to be able to get that one bit of information out at a time. So just to finish with this, let me show you one interesting example. Again, very simple query, same as this one, we have two injection points, ID and type. But the single tick character is filtered out by the web application filer. So there is one character that we can inject here to mess up this horribly. Anyone with an idea? What character would you inject to mess up this query? But you cannot inject single tick. You can say, okay, but you were cheating. You saw this before, I'm sure, somewhere. But yeah, okay. Normally, if it was someone else, I would say I'll buy you beer, but for Tony, you'll get beer anyway. So with backslash, check what you can do. If we inject backslash into the first parameter, ID, check what will happen with the query. Since we escaped this single tick, this all becomes ID, and then actually what we inject here becomes our extension of the SQL query. So even though single tick is, like banned, we can still modify the query. For the lessons learned, blacklisting doesn't work. So there is no way for blacklisting to work ever. Although maybe today you can create a really good blacklisting filter, which will maybe stop everything from being exploited today. Who knows what will happen tomorrow? Tomorrow, database engines might support something new. They might add new keywords that are supported. So blacklisting is actually not the way to prevent SQL injection from being exploited. For any developer that you ever work with, or if you develop your own web applications, the only real way to get rid of SQL injection is to use prepared statements or parameterized queries, which means that the SQL engine will know exactly what is the injected content, and it will prevent that injected content from being interpreted by the same SQL injection language. So any user input must be properly encoded, must be properly filtered, so that way we prevent any exploitation such as the one that I showed to you. And with this, I should be done right on time, maybe even a little bit more than I actually thought. So if there are any questions, please shoot right now. Otherwise, let's go have some beer or whatever, and I can answer questions later as well. I hope you enjoy this. The web application will be on my GitHub hopefully tomorrow, and I think slides will be sent by the organizers or something like that. But if you want them, just let me know, and I'll be more than happy to send the slides to you. So any questions? Yes, no? Beer? Yes, no, yes. Cool, so thanks everyone. Thank you again.